Hi, my name is Jorge Valle, and I'm in the electromechanical system class at the University of Texas at El Paso. And today I'll show you a simple experiment using an ultrasonic sensor and an Arduino to measure distance. Ultrasonic sensors play a variety of roles in automation. The ultrasonic sensor helps us to autonomously measure distance without the need of rulers or a person. They are also very useful to count objects, as in many manufacturing sites they use them to count production. With the construction of this simple Arduino circuit using this sensor, I will understand the principles of the ultrasonic sensor, how to code Arduino to measure distance, and its applications in our daily lives. The ultrasonic sensor has a very simple function. It emits a sound pulse, and if there's an object in the propagation path, then that pulse will come back and the sensor will collect it. The Arduino then will count how long it took for that signal to come back, and then will convert that time into distance using this simple formula. In this specific project, I will consider the speed of sound as a constant, which in this case will be 340 meters per second. To get the distance, we're gonna multiply the speed of sound by the time the Arduino calculates over 2, and it's divided by 2 since the pulse travels the same path twice, as the image below here shows, so time should be divided by 2. This is the flow of computations that we're going to program into the Arduino. The Arduino will first calculate the time it took for the sound pulse to come back. Then it will convert that value into distance with the formula I mentioned before, and then it will decide which LED and or buzzer to turn on, depending on those values. Following the conversion diagram, this is the program decision flow. To identify when the distance is increasing or decreasing, we'll be using 3 LEDs and a buzzer. When the distance is below than 30 centimeters, the green LED will turn on. If the distance is still below 30 centimeters and is also below 20 centimeters, then the green LED and the yellow LED will turn on. When the distance is below 10 centimeters, then the 3 LEDs, green, yellow, and red, will turn on. If it's still below 10 centimeters and it's also below 5 centimeters, all LEDs and the buzzer will turn on. For this project, the components we're going to use are an Arduino, an ultrasonic sensor, a buzzer, 3 LEDs, 1, 2, 3, and a breadboard. This was the code used to program the Arduino. To start, I first declare all of the ports that will be used, followed by which were outputs and inputs. After that, I set the ultrasonic sensor to retrieve the echo and make the Arduino count till it gets that signal. After that, I use the retrieve information to calculate distance. After the Arduino calculated distance, I use a bunch of if and else statements to determine which LED and buzzer must be turned on or off. After that, the code that is left is to look at the data in the monitor. This is the distance that I collected by the test I previously have done.